made the recording on. So I'm going. So the range is very important. So please take a paper, okay, and write it. Class A, 1 to 126. 1 to 126. Suppose if you don't know this range, if any problem comes in subnetting or VLSM, suppose if you get a problem, okay, automatically you will do mistake. Okay, definitely you will do mistake. So these ranges are very, very important. Okay, very important. Okay, you must keep it in your mind. Okay. Now, class A, what is the range means? 1 to 126. 1 to 126 is a range for the class A. Class B, it is 128. 127 is not here. So why 127 is not here means because it is a loopback IP address. Okay, if you want, I'll write it here. So 127, okay, is a loopback IP address. Loopback IP. Okay, it is a loopback IP address. So 127 is not in class A, not in class B. Then class B, 128 to 191. 128 to 191. This is class B. Class C. Class C is 192 to 223. Okay, 192 to 223. This is class C. 224 to 239. This is class D. Class E is 240 to 255. This is class E. So everybody should remember this range, the range of IP address. Okay, you must keep it in your mind. Then the next very important is subnet mask, default subnet mask. Class A, default subnet mask is 255.0.0.0. Class B, the default subnet mask is 255.255.0.0. For class C, the default subnet mask is 255.255.255.0. Okay. For class D and class E, there is no subnet mask. We don't have any subnet mask here. Then the next one is CIDR value. What is CIDR value means? This and this are same. What is that? So 255 means here 111. There are 8 ones available. Okay, so I make this and I'm writing /8. So /8 means number of bits in the network. Okay, IP address we can divide into 2 parts. We can divide the IP address into 2 parts. First part is called the network part. Second part is the host. Okay, the second part is the host part. The first part is the network part. Now /8 means number of bits available in the network. So 8 bits available in the network, remaining 24 bits. Total is 32 because this is IPv4. So total is the 32 bits. So in the 32 bits, 8 bits available in the host, in the network, the remaining bits available in the host. Same here, 16 bits, you can see 255. That means here 8 ones, here 8 ones. So 16 bit available in the network and 16 bits available in the host. Then 255. So this I can write it as /24. Okay, so CIDR value and default subnet mask, it is related. It is related. The other form, you can write this or like this. Okay, there is nothing wrong in this. Okay, now you can see the number of network bits. Number of network bits is 8. Okay, this 8. The 8 bits available in the network. Then the remaining 24 bits. Okay, the remaining 24 bits, it is available in the host. So number of host bits. So if you put the total, you will get 32. Same. If you go for class D, 16 bits available in the network and 16 bits available in the host. If you are going for the class C, 24 bits available in class C, in the network, and 8 bits available in the host. Okay, so this is how you can relate. Okay, subnet mask. Using the subnet mask, you can write the number of bits available in the network, the number of bits available in the host. There, you can see this one. This is called higher order bit. What is this higher order bit means? This bit will be fixed, the first bit. If you take a class A IP address, for a class A IP address, always the first bit will be 0. Okay, it is reserved. You cannot change it. Okay, you cannot make this as 1 for a class A IP address. You cannot. There. This is for class B. The first 2 bits will be 1, 0. The first 2 bits of class B IP address, it will be always 1, 0. Class C, the first 3 bits will be 1, 1, 0. So this is called the higher order bit. So higher order bit, it is not going to change. It is not going to change any time. So it will be always fixed. Then the next bit is the next class D. The higher order bit is 1, 1, 1, 0. Then the higher order bit for class E is 4 ones. This is also going to be fixed. So this table is going to be a very important table. This table already we used this, but I'm giving a summary to you, okay, a revision to you, so that you can easily remember the things. And after this, you can go through your lectures. If you go through your lectures, things will become very easy for you. So this is about, okay, the IPv4 addressing concept. If you have anything in this, if you have any doubt in this, you can ask me now, only in this table. Is it okay? Is it clear? Speak. Is it okay? Yes. Now, okay, very good. Now, I'm going for the next. What is the next one means? The next one is basic subnetting. Okay, the next one is basic subnetting. So this also we have done. We already discussed in our classes. Everything we discussed, but I'm giving a summary to you. Now, if you go for subnetting, the very important thing is you must know how many bits to be borrowed, number of bits to be borrowed. This is very, very important. I'm going to solve one example today. Okay, I'm going to solve one example today. Okay, you can see the bits to be borrowed. How many bits to be borrowed? Okay, you have to find it very clearly. That is very important. Then, how you can fix the number of bits to be borrowed means you can fix this based on the subnets. How many subnets you need? Based on that, okay, you can find. So number of subnets needed. For example, I need 5 subnets means for that, how many number of bits to be borrowed? Bits, okay, the bits to be borrowed. How many bits to be borrowed? So this, okay, you must know how to do it. Okay, so this is based on the number of subnets needed. Okay, based on the number of subnets needed. Then the next one is you can say for each subnet, for every subnet, okay, for every subnet, you have to calculate, you have to find, what is that? You have to find the network ID. Okay, network ID. Some people, they may tell network ID. Some people, they may tell network address. Both same. Both same. Okay, network address or network ID for each subnet. So in our examples, we use the word network ID. So network ID or network address, both is going to be same. So you have to find the network address for each subnet. Then IPv4 address of the first host of this subnet. What is that? First host address. Okay, IPv4 address of the first host on this subnet. This is first host address. You have to find. Then last host address, IPv4 address of the last host on this subnet. Then IPv4 broadcast address on this subnet. So for every subnet, okay, for example, I have 5 subnets here. So this is subnet 1, this is subnet 2, subnet 3, subnet 4, subnet 5. For every subnet, you have to find network address, okay, the first host address, okay, they will play with English, that's it. IP address or first host address, both same. So the first host address or the IPv4 address of the first host, IPv4 address of the last host, IPv4 broadcast address. So for every subnet, 4 things we have to find. One is the network address. Second one is the first host address. Okay, first host, then last host, then broadcast IP address. So this you have to find it for every subnet. Okay, for every subnet, we can find this. So I'm just revising everything. This we have done. I have given a lot of examples for this, but I'm just revising. Okay, you can understand the things now. Okay, now let me go for an example. I will go for an example. I'm going to solve an example for you now. Okay, now network address. Okay, we have given 200. Okay, you see the word network address is given. Network address. What is the network address? 200.100.50.0. This is the major network, the network given to us. Now, this network, I want to make number of subnets needed. I want to divide this into 64 subnets. I want to divide. Okay, I want to divide this into 64 subnets. I want to divide. So how can we do? Okay, you can see the steps. Okay, what is the first step? Step is address. Address class. What is the class of this address? Okay, for 200, what is the class? I'm going for the table which is available before, but in exam it is not allowed like this. You have to keep it in your mind. You have to memorize this. You cannot go and refer somewhere. So 200, I'm just showing. So 200. So for 200, what is the class? This is going to be class C. Okay, it is class C. So I'm going here. So the address class is, okay, C is the address class. Okay, C is the address class. Okay, what is the default subnet mask? The default subnet mask you can see here. It is 255, 255, 255, 0. Now I'm going to write the default subnet mask is 255.255.255.0. This is the default subnet mask. Then number of bits to be borrowed. Number of bits to be borrowed. How many bits you have to borrow? Okay, how many subnets you need? I need 64 subnets. Okay, so for 64 subnets, how many, okay, bits to be borrowed? Okay, we have to find it. Okay, now I'm going 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6. Okay, I'm writing like this. Okay, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, and this is 8, and this is 16, and this is, okay, 32, okay, and this is going to be 64. So if you want to borrow, okay, if you have 64 subnets means you have to borrow 6 bits, you have to borrow. Okay, 6 bits you have to borrow. So the number of bits to be borrowed, okay, 6 bits I want to borrow, 6. Okay, then custom or new subnet mask. So if you borrow some bits, automatically your subnet mask will change. You cannot use the same subnet mask. You have to change your subnet mask. Okay, how can I how can I change? Okay, I will use another paper. Okay, I will do it in another paper. You can see now we already have 255.255.255.0. This is our subnet mask. Now we borrowed here in the last part. How many bits we borrowed means we borrowed 6 bits. So 1, 2, 3, 4, 5, 6. So 6 bits we borrowed. Another 2 bits available here. Okay, another 2 bits available. I make it 0, 0. Now, for this, you have to find the place value. Okay, for this, we have to find the place value. That means this is 1, 2, 4, 8, 16, 32, 64, okay, 128. You have to add everything here. Okay, if you add everything, okay, you will get, that is going to be your new subnet mask. No need to add. What I can do, the total is 255. Okay, the total is, if you make all 8 ones, it is 255. 255 minus 3. Okay, 2, okay, this 3. 2 plus 1, 3. If I minus 3, that is going to be 252. So 252, okay, that is my new subnet mask. 255 dot 255 dot 255 dot 252. This is your new subnet mask. Okay, this is your new subnet mask. Then, what is the custom or new CIDR value? Okay, what is the custom or new CIDR value? Okay, how many bits available in the network? Now, how many bits available in the network? Here 8 bits, here 8 bits, here 8 bits, and here we borrowed. How many bits we borrowed? Means we borrowed 6 bits we borrowed. Okay, we borrowed 6 bits. So now this is equal to, you can add everything total. No need to put the total. The whole thing is 32 minus, okay, only 2 bits left. Okay, only 2 bits left. Okay, you add 8 plus 8 plus 8. 8 plus 8 plus 8 is 24. 24 plus 6, 30. Okay, 8 plus 8 plus 6. So 8 plus 8, 16, 16 plus 8, 24, 24 plus 6, okay, it is 30. So 30 is /30. This is our new CIDR value. Okay, so this is, now you can see here, the number of bits to be borrowed is 6. Custom CIDR, what is the custom custom network mask means 255 dot 255 dot 255 dot, okay, 252, okay, 252 is our new subnet mask. What is the CIDR value? /30. This is our, okay, new CIDR value. Then you can go for the first subnet, second subnet, third subnet, okay, like that. All 64 subnets you can find, but no need to find all 64. First 2 or 3 I will find it. Okay, that is enough. Now I'm going for the first subnet. So every subnet will have, okay, you can see every subnet will have a network address. Every subnet will have a network address. Every subnet will have the host, that means the first host, address of the first host. Every subnet will have the last host, and every subnet will have the broadcast IP address. Each subnet, for every subnet, 64 subnets available in this case. 64 subnets available here. Okay, now I'm going for the first subnet. Okay, I'm going for subnet 1. For subnet, first subnet, I want to find 4 things. You can say network ID or you can say network address. Okay, anything. I want to find network ID or network address. Then I want to find the first host address. Okay, or first host IP address. Okay, anything. Then I want to find the last host ID or last host IP address. Then last one, I want to find the broadcast IP address. Broadcast, okay, IP address. So all these things I want to find. Okay, now let me take, okay, I'm going for this, okay, given 200. You see how I'm writing. So 200 dot 100 dot 50 dot, so here only we borrowed. Okay, here only we borrowed. How many bits we borrowed? We borrowed 6 bits. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6 bits we borrowed. Remaining 2 bits available here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going for subnet 1. Sometimes they may give subnet 1 or they may start with 0 also. Subnet 0, anything is correct. Because generally it will be Subnet 1, if you put, that is equal to 0 only. You have to start from 0. Okay. So subnet 1 or subnet 0. Okay. How to find the subnet 0? Make everything 0. 0, 0, 0, 0, 0, 0. So this is okay for the first subnet. Or we can say subnet 0, no issues. Now, what is the network ID means? This is equal to network ID or network address. This is equal to 200.100.50. Everything is 0 / new CIDR value. What is the new CIDR value? 30. 30 you have to write, not 24, because subnetting. So hereafter, you are going to follow only the new CIDR value, custom CIDR value only you are going to follow. Okay, because you are done subnetting. Next, I'm going for the first host IP address. Okay, how to calculate the first host IP address? In the host part, make the last bit 1. Make the last bit 1 in the host part. So this is equal to 200.100.50.1. Okay, /30. Then, what is the last host IP address? So last host IP address means in the host, make the last bit 0. Okay, remaining everything is going to be 1 in the host part. Only 2 bits available. So make the last bit 0 and here it is 1. So now this is equal to 200.10.50. Okay, this is 1 and this is 2 place value. This is 2. This is the last host ID. Okay, /30. Then, what is the broadcast IP address? So the broadcast IP address means make everything 1. Make everything 1 in the host part. So I make everything 1. So 1 means this is 2 plus 1, this is 3. So 200.10.50.3. This is going to be the broadcast IP address for this subnet. Okay, for this subnet. So this is for subnet 0. Okay, if you make it as 1 also, there is nothing wrong. Okay, 1 means it is going to be 0 only. Now, I'm going for subnet. Okay, I'm going for, this is the first subnet. We are going to say subnet 0. I'm going for the next subnet. It is subnet 1. Okay, now I'm going for the next subnet, subnet 1. Teacher, I write 1 and I write 2 here. Nothing wrong. Okay, totally you will have 64 subnets. That's it. I'm going for the next subnet. Okay, now here, what is the network address? What is the network address? Means, okay, same thing. 200.100.50. Here there are 8 bits. We borrowed 6 bits. 1, 2, 3, 4, 5, 6 bits we borrowed. Okay, so this is the first subnet. So I'm going to make 1, the binary value 1, 0, 0, 0, 0, 0. I'm going to make this as 1. Here I made everything 0. Okay, this is 1. Next subnet means it is going to be 1, 0. Next subnet 1, 1. So next subnet 1, 0, 0. Okay, like that. The binary value is going to change. Now this is 2 bits is going to be 0. Okay, network address is equal to 200.100.50. You have to know what is the place value. Place value means 1, 2, 4. That is the place value 1, 2, 4, 8, 16, 32, 64, 128. This. So this is 4. Now you can see 50.4. This is going to be your network address. Okay, this is the network address. Actually, if you apply, if you think this is okay, the previous subnet is over here, automatically the next address will come here. Okay, this is shortcut to check answer. I'm telling to check. See, here 3 is available. If you do this, automatically 4 is going to come here. Whether you are doing all calculation or not, 4 will be the correct. Okay, so it is finished. The next subnet is finished in 3. The previous subnet is completed in 3. Automatically, it is going to be 4 now. Now, I'm going for the first host IP address or IP address of the first host, anything. Okay, what is the first host IP address means? We have to make, okay, the last bit 1 here. Okay, you have to make the last bit 1 here. So if I make last bit 1, already 4 is available. So 4 plus 1 is going to be 5. So now the first host IP address is 200.100.50.5. This is going to be the first host IP address. Okay, /30. Then what is the last host ID? What is the last host ID? The last host ID is you make everything 1 except the last bit 0. So now I'm going to make this 1 and 0. Okay, you have to make like this. All bits you make it 1 except the last bit. The last bit is 0. Now you can say, okay, 1 0 means already 4 is available here, and this is going to be 2. The place value for this is 2. So 4 plus 2 equal to 6. So 200 plus 100 plus 50.6. This is going to be your last host ID. What is a broadcast IP address? Okay, IP address, IPv4 broadcast IP address for this subnet. Okay, what is a broadcast IP address means? You have to make everything 1. The host bit, everything you have to make it 1. So already 4 is 1, 4. Now 4 plus 2, 6, 6 plus 1, 7. So now 200, okay, 200.100, okay, 100.50.7/30. This is going to be your broadcast IP address. So for every subnet, there is a network address, there is a IPv4 first host ID or first host address, last host address, and broadcast IP address. Okay, this is you have to find. So you are going to continue like this. In exam, they will not ask like this. They will not ask, okay, for all 64 subnet, if you calculate, the exam time will be over. So they will ask you for only one subnet or 2 subnets, okay, like this. Okay, I think you understand the concept. Okay, I revised. Okay, I revised this concept. Okay, now I'm going for one more problem here. Okay, you can see this problem. I want everybody, okay, to see this problem and give me the answer. This problem will be slightly twisting, not twisting, slightly reverse. Okay, same. If you understand the previous one, you can answer this. Now, I'm going to give it to you. Okay, the students can answer this. Now, all of you listen. IP address, okay, IP address, host IP address. They are giving one IP address to you. Okay, what is that? 182.35.50.5. Okay, this is the IP address. Now, original subnet mask. Original mask means before subnetting, this is the original mask. Now, they have done subnetting. They have done subnetting. The new subnet mask they are giving. Okay, what is the question now? The question is how many subnets they created? How many subnets they created? What is the network address of this subnet? Okay, what is the first host? Okay, this is a subnet for this. Okay, this one. For this, what is the first host IP address? What is the last host IP address? What is the broadcast IP address? You have to find. So slightly reverse. Okay, now I will give you the clue. You can see. All of you take a paper. I need you, okay, to answer this question, please. Now, 255.255.00. This is the original subnet mask. This is the original subnet mask. Means what is the class? What is the class of this IP address?
B.
Very good. Now I'm writing this is class B. Okay, I write it. This is the way you have to answer. See, class B. Okay, very good. Now, what is the next one? New subnet mask. Okay, they are taking. Okay, what is the original subnet mask? Original subnet mask is 255.255.00. This is the original subnet mask. New subnet mask is 255.240.0. This is new subnet mask. So 255.255, this is original, but they borrowed some bits here. They borrowed some bits here. So now you have to find how many bits they borrowed. Same like previous. In the previous example I have done. Okay, in a reverse way. Now we are going in a reverse way. Can anybody? If 240 means here, how many bits will be 1? Take a paper and do it. I'm waiting for your answer. Did you understand the question first? Did you understand the question first?
Yes, Mr.
Did you understand?
No, Mr.
Question is clear or not? I'm asking question.
No, Mr.
No. Question is not.
No, Mr.
Yes. I repeat the question. Anybody else? Question is clear or not? Anybody else? Anybody understanding what I'm telling? Please, if you understand the question, you can tell in Arabic. You can convey it in Arabic. That's why I'm telling. Anybody ready? Speak. Okay. Shall I explain the question again? Shall I repeat the question again?
Yes.
Yes, I repeat the question again. Okay, very good. Now, what is the question means? Okay, it's nothing, just a reverse approach. Whatever we have done before, before what they do, they are giving okay, they are giving number of networks. I need 10 networks. How many bits to be borrowed? You are finding. Now, they are giving number of bits borrowed. Okay, how many bits borrowed? They are showing it to us. We have to find how many subnets. This is the reverse. Okay, this is the reverse. Now, you see, this is your IP address. Okay, keep this IP address with you. Now, this is the original subnet mask. Original subnet mask means before subnetting. This is the subnet mask. Now, new subnet mask or custom subnet mask. What is a custom subnet mask means? This is the custom subnet mask. Custom means after subnetting. After subnetting, this becomes like this. Okay, it becomes 240. Okay, now what we have to do? We have to find how many subnets created. Okay, how many subnets created? We have to find this. Okay, now what I'm going to do means, listen carefully. I'm taking 255.255.0.0. This is the original subnet mask. Okay, after subnetting, this is becoming 255.240.0. It becomes like this. So that means this is class B. This is class B. So in this class B, they borrow something here. They borrow something here. Okay, you see, they borrow something here. That's why this is becoming 240. Okay, it becomes 240. Now, how many bits if you make one here? Okay, you will find. Okay, 240. Okay, nothing. See, this 255 means 1, 2, 3, 4, 5, 6, 7, 8. Then this 255 means 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. All 8 bits. If you make one, it will become 250. Now, this 240 means what? To bring 240. Pardon?
4 bits.
4 bits. Think and tell. What is the total? Total is 255. They make 240. How many bits they will make here? 1 to bring 240.
4 bits, Mr. 128.
128. Okay, very good. Come on. 128 plus
64.
No. I want. Okay, 1. Okay, the binary value I need. That is very simple. 240 binary value. What is the binary value for? No. Binary value for 240. If you take binary value for 240, you will get the answer. That's it.
0, 0, 0, 0, 1, 1, 1, 1.
No, wrong. 240 is 240. See.
16?
No. Binary value I'm asking. So listen, 240 divided by 2. Okay, so this is 1, 2 is 2. Here 4. 2 4s are, okay, 2 2s are 4. 0. Remainder 0. Okay, actually this no need, actually I'm doing, but this is no need. Easily shortcut I will tell. See, again I divide this by 2. I want to convert this into binary. Okay, now Next one is 6 2s are 12, 0, balance 0. Actually, no need to do this, but anyway, try to understand. 60, 30. 30 into 2, it is going to be 60. Remainder 0. Then, again 2. Okay, I'm dividing it by 2. 15 2s are 30. 15 into 2, 30. Remainder 0. Then, 2. 7 2s are 14. Okay, that means this 240 you have to convert into binary. Okay, 7. So 7 2s are 14. So, 7 2s are 14. Balance is 1. This is 1. Remainder 1. 7 into 2, 14. But I have 15 here. So the remainder is 1. Okay, I have 7. Then again, I'm going to divide this by 2. So 3 2s are 6. 3 2s are 6. Balance 1. Balance 1. Okay, here I have 3. Okay, I put 2. So 1 2 is 2. 1 2 is 2. Balance 1. Okay, now you can see you have to write it from here. You have to write it from here. So 1 2 3 4 5 6 7. Okay, there are 7 bits available. Okay, so 1 1 1 1. Okay, 1 1 1 1 0 0 0 0. Okay, 0. So now you see 240 is equal to this. That means 1 2 3 4 4 bits they borrowed. They borrowed 4 bits. This is actually, this no need. This is actually what to say, it's going like this. I will do it in a very simple way. 240 is here. Okay, wait. 240 here. Total is 255 is the total. So 255, 240. Okay, 255, 240. So if you minus, you will get 15. Okay, you will get 15. So what is this 15? You have to make it off. Okay, you have to make it off. Okay, no problem. What is 15 means? 1, 2, 4, 8, 16, 32, 64, 128. Now you see, if you make 15, if you I want to reduce 15, how can I reduce 15? 8 plus 2, 10, 10 plus 4, 14 plus 1. So 0, 0, 0, 0. If I make this is 15. 15 gone. The remaining thing, if I make, this is going to be, okay, 240. This is 240. See, 8 plus 4, 12. Okay, if you use calculator, it is easy. I'm not using calculator, I'm doing directly. See, 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. So 15 I want to reduce because 240 is available. So if I reduce, I make 0, 0, 0, the remaining thing. So this is going to be my binary value. Okay, you can use calculators in exam. Okay, if you have, directly you can convert this 240 into binary. That's it. You understand what I'm telling? Did you understand the concept? Did you understand the concept? Calculation, you can do it by using calculators. That is no problem. I'm telling concept.
Yes, Mr.
Yes, Mr.
Yes, very good. Now you see in this, okay, in this is the IP address. Okay, this is the IP address. Very good. Original subnet mask is 255.0.0. Now the new subnet mask is 255.240.0. Okay, now what is the question means? How many subnets created? So how many subnets created means, first thing you must know how many bits borrowed. Okay, so bits borrowed. So how many bits borrowed here? We already saw that 4 bits borrowed. Okay, how many bits created? How many subnets created? How many subnets created means this is nothing. This is 2 to the power of 4. 2 to the power of 4. So, okay, in the previous example, okay, I gave this 2 to the power of 4. What is 2 to the power of 4 means? 2 into 2 into 2 into 2. So this is 4, 4 into 2, 8, 8 into 2. This is equal to 16. So 16 subnets they created. In the previous example, we give this directly. Number of subnets needed, 16. How many bits to be borrowed? You will calculate this. Then what is the new subnet mask? You follow this. Okay, you go in this way, but now they are coming in the reverse. Okay, very simple. You compare this original and new. Okay, the difference is available here because this is class B. So in class B, first two you are not going to touch. Only the third one you are going to take. So 240 convert into binary. If you convert this 240 into binary, you will find how many bits borrowed. Okay, how many bits borrowed. Then number of subnets created is 2 to the power of 4. This is equal to this. Okay, did you understand this? Is it clear?
Yes, Mr.
Shall I give one more problem for you? Can you solve the problem now?
Yes, yes.
Yes, I'll give one more problem to you. Come on. Okay, all of you, that's why I told, please take the paper and pen. Okay, now I'm going for the next problem. I want you to find. Let me see how many of you are doing. So host IP address. Okay, host IP address, please take it 194.72.10.1. This is the host IP address. Okay, original subnet mask or original mask. Original mask is, because this is class C. So original mask is 255, 255, 255, 0. Okay, this is original mask 10. What is the new subnet mask? Okay, what is the new subnet mask? The new subnet mask also I will give. New subnet mask. New subnet mask is 255.255.255.252. 252. Okay, 252 is a new subnet mask. So find how many. Okay, find how many subnets created. How many subnets created here? Come on. Okay, how many subnets created here? Come on. Okay, just 2 minutes break. I'm just going. Okay, I'm coming. You can solve the problem. Don't leave the meeting. I just keep the meeting on. Just yes. Anybody give the answers? I got one answer. Asma, very good. Okay, I don't know whether it is right or wrong. Anybody else? How many bits totally borrowed here? No, my question is very simple. How many subnets created? You are answering subnets created. I'm asking how many bits borrowed here? 6, 6, 6. Very good. Really very good. I appreciate that. Very good. Yes, 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 yes. I'm very happy. Next. How many subnets created? 2 to the power of 6. 2 to the power of 6. Yes, very good. This is enough. We'll go to the next. Yes. Okay. So number of bits borrowed here. Okay. You can see 252. 252 I'm having. Okay. Go in a shortcut way. You can convert this into binary. You will get the answer. Okay. If you are comfortable with that, do it. Otherwise, total is 255. I have 252 here. That means 3 is missing. We have to reduce 3. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. In the 8 bits, I want to reduce 3. If I reduce 3, it will become 252. So how can I reduce? Go for the place value. Place value is 1, 2, 4, 8, 16, 32, 64, 128. Okay, so now we want to reduce 3. Simple. 2 plus 1, 3. Make 0. Make 0. Finished. So 1, 2, 3, 4, 5, 6. So 6 bits borrowed here. Okay, 6 bits borrowed here. Okay, so number of bits borrowed is 6. There. How many subnets? How many subnets we can create here means 2 to the power of 6 subnets is created here. 2 to the power of 6. So 2 to the power of 6 means, okay, so 2 to the power of 0, 1, 2, 3, 4. Okay, if you write, it is going to be 64. So 64 subnets created in this case. Okay, very good. Now, I go to the previous problem. I'm coming to this problem. So in this problem, so we already found bits borrowed is 4. So number of subnets created is 16. So number of subnets created 16. Finished. Then, what is the network address? Okay, all of you look at the paper very carefully. What is the network ID of this subnet? Okay, they are giving, okay, IP address. Take this IP address, 182.35.50.5. Okay, this is not network address. This is an IP address. For this, what is the network address? Okay, we have to find. Okay, I will give the formula. You find it. What is the formula? The formula says you have to make all the host part 0. Make the host part 0. You have to make everything 0. Okay, can anyone? You make the host part 0 and give me the answer for this. If you want, I will write the subnet mask 255.255.240.0. Okay, so this is the new subnet mask. Can anyone make the host part? Host part, you have to make everything 0 and you give the answer. What is the answer for this? Network address or network ID? Anybody? You are typing in chat. 182.35.0.0. Okay, 50.0. Very good. Some answer I'm getting. Yes. Why there is difference? Okay, one student, she is telling 182.35.0.0. The other student is telling 182.35.50.0. 50.0. Okay, there is a small difference. There is a small difference. Okay, available 50, 50. Now we are getting all 50. Very good. Now, okay, see, this is the place you have to think. What is that? See, 255. We are taking this. There is no change here. 255. There is no change here. And here 250. This also you cannot change because you borrowed now. Okay, you borrowed. So now only in this place you have to make everything 0. So the subnet ID, what is the subnet ID means? 182.35.50.0. This is going to be your subnet mask. Sorry, network ID. Okay, that's why I'm writing like this. Now, IPv4 address of the first host address. Come on, first host ID, last host ID, broadcast IP address. 3 things I need. What is the formula here for the first host? You have to make the last bit 1. The formula for the last host, you make everything 1 except the last bit 0. And what is the broadcast IP address? The broadcast IP address, make everything 1 in the host part. Come on, do it. Come on, find it. First host. It is in class B. Very good. Some student is asking it is in class B, but now it is not in class B. Now we borrowed some bits. Okay. If it is in class B, you can make this 0. Very good. Some student is asking it is in class B. Okay. It is in class B. It was in class B. We borrowed 2240. Now there is no class for this. Now there is no class for this. We borrowed two, okay, the bits, how many bits we borrowed means, so we borrowed, okay, the bits borrowed is 4. So 4 bits we borrowed. Okay, come on. I need the first host IP address, last host IP address, and then broadcast IP address. Okay, I need. Come on, try. Asma, very good. First. Correct. Then what is the last host IP address? No, also correct. Very good. Last host IP, very good, finished. Asma is good. Okay, completed. 182.35.50.254. Broadcast IP address? No. Not 2. 2 is not going to come. 2, no. Can anyone write? Okay. First host ID, FHID. Last host ID, LHID. Broadcast IP address, BIP. These 3 things, okay, write it at the same time. Even if it is wrong, no need to worry. You are learning. Okay. First host ID, last host ID, broadcast IP address. Yes. Allah, good. Last host ID. Yes, broadcast IP address. Please everybody see the chat box. Please see the chat box. Please see the chat box. Yes, broadcast IP. Very good. So this is the way. So this is the maximum. Okay. What to say? If okay, you can find. Okay, if you are going for the subnetting concept, this is the maximum. Okay. So if you understand this, it will be very good. Okay. Shall I go to the next one? Second lecture, IPv6. Okay. Now I'm going for the next lecture. The next lecture is IPv6. Okay. I'm focusing only on the problem solving. Okay. I'm focusing only on the problem solving. Now I'm going for the second lecture. The second lecture, IPv6. In IPv6, the first type of problems we can expect is, okay, there are 2 rules available. Okay, you can go for the 2 rules. Please write the rules in the paper. Rule number 1. What is the first rule means? The first rule says omission of leading zeros. Please write it. Omission of leading zeros. Okay, omission of leading zeros. So leading zeros means the zeros which is available in the front. Okay, that is the omission of leading zeros. Then the second rule. What is the second rule means? The second rule says, okay, omission of all 0 exters. Okay, omission of all 0 exters. This is the 2 rules. You can write these 2 rules in your paper first. Rule number 1, rule number 2. These are the 2 rules. Omission of leading zeros. Omission of all 0 exters. Omission of leading zeros and omission of all exters. So these are the 2 important rules. Okay, now we are going to apply both the rules for a IP address. Okay, now you can see I have some list of IP address. Okay, for your last exam, I told there is a open book test. For this, okay, these types of questions I will give. That's why I'm giving you the practice. Now, this is the IP address. Can anyone, what is the length of IPv6? How many bits? How many bits? What is the length of IPv4? Sorry, IPv6. What is the length? The length of IPv4 and IPv6. Okay, write both. Please write it, write it. These are all basic concepts. See, IPv4, we already discussed in the last, okay, that means before this, it is 32 bits. Write it. It is 32 bits. IPv6, it is 128 bits. The length of the IP address is 128 bits. Okay, IPv6 length is 128 bits. Okay, now rule number 1. I'm going for the rule number 1. What is the rule number 1 means? You have to omit the leading zeros. Leading zeros means the zeros which is available in the front. Okay, now you see, this is your IP address. This is your IP address, IPv6 address. Now, in this IPv6 address, I want to remove, I want to apply first rule. Rule apply, rule number 1, I'm going to apply. So what does that means? Omit the leading zeros. Omit the leading zeros means, you see, these 2 zeros you can omit. Okay, I'll make it in the red. So these 2 zeros you can omit. This is leading 0. And then here there are 4 zeros available. So first 3 zeros only you can omit. Okay, if you make all 0 omit means the problem will be there. So three zeros I'm going to omit. Then here there is nothing. Here 0 to AA. So this 0 I can omit. I can leave. I can remove. Then 0, 0, FF. These 2 zeros I can omit. Then remaining thing is, okay, as it is, I'm going to write. So 21, DA, D3, okay, double colon, okay, this is colon, then 0, colon, 2F3B, okay, colon, AA, colon, FF, colon, FE28, colon, 9C5A. This is the after applying first rule. After applying rule number 1. Okay, after applying rule number 1. Okay, now please take a paper and give me the answer for this. Write your answer in the comment box. Apply only rule number 1. Type your answer in the comments in the chat box. Apply rule number 1 and show me the answer. Leading zeros, not in between. If you do in between, it is wrong. Leading zeros means the zeros which are coming in the front. Okay, not in between. 2001 real my salary. 2001 real my salary. For example, now what you make? You make 21 real my salary. Example I'm telling. Leading zeros, not in between, not in between. If you make in between, it is wrong. Leading zeros. Please kindly remove only the leading zeros. Try others also, please try. I got only 2 and 3 answers. Please try. Asma, you can give your answer again. Repeat your answer. Do the changes and send it again. Asma, change your answer. Do the correction.
Okay,
Nothing
Mr.
to worry if, yeah, change it and send it. There is nothing to worry. If you do mistakes, you are learning. If you are not giving any answer means you are not learning. Change your answer and give it Asma. Yes, very good. Very good, very good. Yes, so most of the students are giving the answers correctly. Okay, all of you look at the screen now. See, leading zeros, 2001. There is no leading zeros. I have to take 2001 colon. Then the next one is 0, 0, 0. There are 4 zeros available. So 3 zeros I can remove 0. Then here I have 4 zeros. So 3 zeros I can remove 0. Then A, B, C, D. You cannot do anything. You have to take it. Then all F. F you have to take it as it is. Then here 4 zeros available. So 3 0 I can remove. Here 4 zeros available. 3 zeros I can remove. And here 3 zeros available. Okay, I can remove and I can make it 1. So this is the answer. Okay, so this is the answer. Now, okay, so this is rule number 1. Okay, go for this because there is one more thing here. Can anyone solve this? Write the answer. Write the answer in the chat box.
Victor, repeat the question, please.
No, this one. F, the last question. Can you see that? The last. Are you seeing that? Can you see this question?
Yes, Mr.
Apply rule number 1. Apply rule number 1. Leading zeros. Apply rule number 1. Anybody give the answer? Let me check it. Leading zeros, leading zeros, leading zeros. Leading zeros means the zeros which are coming in the front. Try to understand. Try to understand. That's why I'm giving second time. After, okay, see, 1000 real. I'm writing 1000 real. You are removing 1000. You remove 00. It will become 1 real. You cannot remove something, okay, which is after. You have to remove only in the front. Okay, the value, the meaning will change. If you remove FC 00, if you remove 00 and write FC means the value will change. 2000 real. You are removing 2 zeros and you are writing 20 real. Both are not same. Both are not same. You cannot remove zeros after you cannot remove. You have to remove zeros only in the front. That is called leading zeros.
Victor,
Yes. Yes.
You mean the 0 in the first just?
Yes, in the beginning. See, I will give example. I will give example. See, speak. If those who are not understanding, kindly speak. See. 2000 real, I'm writing like this. Okay, now remove the leading zeros means you can remove these 2 zeros and write you can 2000. I'm giving 2000 real like this. What you are doing? You are removing this and writing as 2 real. Not same. In the leading zeros only you have to remove. In between or after this you should not remove. If you remove, value will change. The value is going to be different. Okay, think and do it. Okay, those who already gave the answer, you can correct your answer, no problem. Come on. That's why I gave this problem. Wafa FC0. Okay, anybody did mistake? Allah. Okay, please change your answer. Asma also, Asma she has given the correct answer now. Okay, very good, great. Now I'm going to explain this because I want to cover so many things for you today. See, FC00, you cannot touch this. You cannot touch because this is not leading zero. So you have to write it. Okay, FC00, you have to take it as it is. You cannot do anything. Then here you have to remove 3 zeros, you have to remove 0. Then here also you have to remove 3 zeros, 0. Then here you can remove. Okay, you can 3 zeros you can remove here, 0. The same thing here, you cannot remove these 2 zeros, you cannot remove because the value will change. So 3E00. Then 1275 you can write as it is. So this 3 zeros you can remove, so 0. Then 2 zeros, these 2 zeros we can remove. This is leading zeros. This is coming in front. So you can remove this. This will become 34. This is the answer. Okay, this is rule number 1. Okay, if you are giving the answer the same, okay, many students, okay, I'm checking, yes. Okay, most of you have given the correct answer. So this is about, okay, rule number 1. Now, I'm going for the second rule, rule number 2, I'm going. So what is the rule number 2 means? The rule number 2 says, omission of all 0 hectares. 0 hectares. Hectares means bunch. Okay. See, this is called 1 hectare. This is called 1 hectare. This is called hectares. Now, if continuously zeros comes, we can remove it. This is rule number 2. Okay. Now I'm going to write this. Okay. Look at the paper. So 3ABC. Okay, 0001, then ACAD, then this is continuously zeros coming, 2 blocks or 2 hectares, continuously zeros. So I can remove this. Okay, I can remove this. Now I'm going to put double colon. So double colon, after this, whatever coming, I'm going to write 1, 2, 3, 4. Okay, colon 000 colon 0005. This is called omission of 0 hectares. In your IP address, only one place you must have this double colon should be available only one place. It should be available in only one place. You cannot have 2 times this double colon. You cannot remove 2 times. In only one place, okay, you can remove, okay, you can have this. So this is the answer for this. Can anyone try this?
Mr. Complete, its answer is not complete.
Why it is not?
Because the 0 in the first.
Very good. You are 100% correct. But I apply only rule number 2 now. 100% correct. Okay. I apply.
Okay, Mr. If we remove the 0 in the first, it's correct?
That is the next one. Both rule 1 and 2 you are going to apply. Correct. Both correct. Okay, what you are saying is also correct. Okay, what you are telling, you can ask me to remove these leading zeros. Am I right? You are asking me to remove the leading zeros. That is also correct. That is rule number 1. So both rule, if you apply, that is 100% correct. But now we are learning about rule number 2. We are now learning about rule number 2. Okay. So already rule number 1 we finished. Rule number 2 we complete. We are doing now. After this, these 2 rule we will apply same time. Both 1 and 2 we will apply at the same time. Okay. Now, can anyone give me the answer for this? Apply only rule number 2. Give me the answer for this question in the chat box. Already I got some answers. Good. No, remove 0. Wafa, remove 0. It's also not correct. Okay, some students are doing small mistakes, but you are all trying. Very good. You are all trying. It is very good. But some student, Rokaya is correct. Yeah, Ishra is also, yes, Ishra is also correct. Okay. Yeah, almost you are getting the correct answers. Wait. Okay, I'm doing the problem. You will understand very easily. Okay, come on, see this, students. F00, FC. Okay, I'm taking the first one, no change. Then you see the continuous blocks here. This is continuous zeros. Continuous zeros. Okay, I can remove this. So if I remove this, so colon 3E00 colon 1275 colon. Okay, this you cannot remove now because only one place you can have double colon. You cannot remove this 0000. We are applying only rule number 2. Okay, this is the answer. Okay, so this is the answer. So please check your answers with others. Okay, please check your answers. Others, please check your answers. Okay, now I'm going for the last one. Can you answer this? Can you answer this? Apply rule number 2.
Which master?
Last one, this. Apply only rule number 2. Only rule number 2. Yes, I'm getting answers. 3F0. Good. Now you understand the concept. Okay. Some typing mistakes, no problem. So now you understood the answer. Very good, very good. Okay, I'm getting a lot of answers now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost 10 students are giving the answers. Very good. Now, so let me solve it. You can check your answers now. Please, all of it, please check your answers. So first 3F00. So 0090. Now we have continuous zeros. So double colon. So 0098 colon 0000 colon 0001. Okay, this is the answer. Okay, please check it with your, okay, so please check your answers with this. Okay, this is the correct answer, but I'm very happy many students who gave the correct answers. Okay, now I'm going for the next one. I'm not going to give the answers, only you have to give the answer. Any 2 problems we will take. I'm taking 2 problems. This is the first problem. Apply both rule number 1 and rule number 2. This is the first problem, and this is the second problem. Problem number 2. Okay, problem number 2, problem number 3. I want these 3 problems you have to answer. Come on. Apply both rule 1 and rule 2. Okay, first go for problem number 1. All of you please go to problem number 1, solve it, then we'll go to the second. Apply both rule number 1 and rule number 2. Come on. For the first one, I need the answer for the first one. Both. Okay, both apply and give me one answer. It should be a single answer. You cannot apply two answers. You cannot give. For first one, you can give only one answer after applying both the rules. I want this first. Okay, some student giving all. Do it very carefully. In your IP address, double colon should be available in only one place. Only one place you can have the double colon. Then the next very important thing is you cannot leave any block. Suppose 00 coming to two places, if you are having, means you cannot completely remove. It will be wrong. We will concentrate on first problem. First problem, okay. Problem number 1, please do it. Don't answer for the second now. Okay, because it will confuse the students, others. Okay, shall I give the answer for the first? I'm giving the answer for the first. Okay, then we'll go to the second. Okay, all of you listen. First thing, these types of problem, how you have to do means, leading zeros, please remove. Okay, that is rule number 1. Okay, here there is no leading zero. So here leading zero is available. Here leading zero is available. Then here leading zero. Here leading zero, and this is also leading zero. This is step number 1. Then continuous zeros you have to remove. Okay, now you can see continuously here we have, okay, 8 bits, and here also you have continuously. Okay, you have continuously 8 zeros you have. So you can remove this or you can remove this. Anything, up to you. Okay, there are 2 answers for this. Listen, how 2001. I remove this block, continuously I remove this block. So I put double colon here. Then, okay, listen, okay. Don't write it in the comment box, please listen. A, B, C, D. Then colon, F. Then here I remove 3 zeros, okay. 0 should be there. I'm seeing some students, you are not writing this 0. Wrong. Then here 1 0. Then this is 3 leading zeros and 1. This is also correct. I will write it in another way. What is that? See, 2001 colon. I remove 3 zeros here. I take the last 0. I remove first 3 zeros. I take the last 0. Then I'm going for A, B, C, D. Then F. Then this continuous blocks I'm going to remove. Okay, I'm going to remove these continuous blocks. I'm going to remove. So double colon 1. This is also correct. Okay, this is also correct. Try to understand. Okay, try to understand. So you can remove anywhere in the front or remove, because both are equal. Both are 8 bits, 8 bits. You can remove anywhere. Do you understand this? Okay, you can remove anywhere, either in the first or in the beginning. Okay, that means in the first or in the last, anything, because it is equal. It is equally 8 bits, 8 bits. Okay, so you can remove anywhere, you can remove. Now, go to the second problem, problem number 2. Go to the second problem and give me the answer. Already you have given, I think, many students, they already wrote the answer for the second also. Yes, very good. So I will go for the, okay, do it. I'm giving time. Second, for the second problem, give your answers. Problem number 2. Those who have already done, no problem. You can leave it. Go to the second problem and give the answers. 2000. No. Zainab. Remove the continuous zeros. Remove the continuous zeros. Continuous zeros not removed. Leading zeros not removed. continuous zeros. Okay, remove the continuous zeros. Still some students, some logical mistakes you are doing. 2 0 0 0 you cannot remove. You cannot remove after you cannot remove. 2000 real, now you are writing as 2 reals. $2,000 double colon A B C D, then why again 4 zeros coming? Zainab, why again 4 zeros coming? Remove that 4 zeros, remove the 0 0. Yeah, remove, apply both rules. Apply both rule. Apply rule number 1, rule number 2, both. In exams, they may give, they will give, okay, they will ask you to do both. Tushra, 2000 double colon A B C D. Okay, 0 25. Very good. Ishra is correct. Ishra answer is correct. Yes. Now let me do it. Small misunderstanding only. Okay. See, 2000 you cannot do anything. You cannot remove these zeros because in this block only leading zeros, the zeros which is available in the front, only that you can remove. So 2000 I'm taking. I cannot remove anything. You see, this is continuous zero block. Continuously zeros coming. So I'm very happy. Remove it. So I put double colon here. Everything in that zeros. Then A, B, C, D. I cannot do anything. A, B, C, D. You can take colon. And here you have to remove the leading zeros. That is rule number 1. This is rule number 2. We already finished. Rule 2 is over. I applied. Now I'm going to apply the rule number 1 here. Leading zeros I'm going to remove. So 0. Then here also I want to remove the leading zeros. So the leading zeros I'm going to remove. Okay, this is rule number 1. So, and this is going to be 25. So this is my answer. 2000 double colon ABCD colon 0 colon 25. Okay, this is the answer. Now go to the last one. Very interesting question. 3. Let me see how many of you answering that. Yes, almost everybody is answering. Okay, everybody is answering. Ala, Noof, okay, Joka, Rakaya, Gadir. Okay, very good. Yes. So the answer for this problem is, so you can remove the continuous zeros. You can remove. You see, up to this it is up to this it is continuous zeros. Okay, I apply rule number 2. So what is that means? Double colon. You cannot write before 0, okay, because everything is 0, so double colon. Here I remove this 000 also. I'm going to remove. This is rule number 1, so 1. This is the answer. Okay, this is an IP address. Okay, double colon 1 is an IP address. Okay, it is an IP address in IPv6. Okay, so hope you understand. Okay, hope you understand. Okay, how to solve these problems. Okay, now I want to go for the last one in this lecture. Okay, I'm giving summary, the overall idea I'm giving. Okay, the next one is very important is, okay, I think somebody sent a mail to me long back. Teacher, can you repeat IPv6 address? Okay, I'm giving. Now, see, the next one is IPv6 address types. There are so many different types of IP address available, but for you, okay, not everything. Take a paper and write it. This is the complete diagram. I'm going to give only whatever you study in your course. Okay, see, can anyone please answer me? Answer this question. Okay, I'll give you a question. 10.75.4.43.21. What is this IP address? What is the class of this IP address? What is the class of this IP address? Class A, class A, class A. Very good. How you are telling it is class A? Because you know the range. Okay, you know the range. So 10. So 10 is available in class A. Okay, now I'm going to show, okay, all of you look at the screen now. I want to find what is the class of this IP address. Okay, what type of IP address it is. This is IPv6. This is IPv6. I want to know what is the class of this, or not class, what is the type of this. Okay, type of this address. Okay, you can say FC00. What is the type? Okay, what type of address it is. Okay, so if a IP address, we have to find what is the class. Okay, now these are the complete list, but you are not going to study everything. Okay, you are not going to study everything. You are going to study only few things we are going to study. Okay, so please note down whatever you want to know. I will just give that. See, if you take IPv6 address, there are three types. One is unicast. Second one is a multicast. Third one is the anycast. Okay, there are three different types available: unicast, multicast, anycast. Okay, anycast. So these are the three different types available. Now, in unicast, there are so many things available, but in your lecture, not everything is given. Whatever given, I make tick. Okay, only that if you know, it is enough. So unicast. I'm going for the unicast. In unicast, global unicast. This is first. Then link local. This is the second. Then loopback. This is the third. Then the fourth one is unique local. Okay, unique local. So global unicast. This is very, very important. Link local. Loopback. Today we discussed about this loopback. I will show that. Then unique local. Okay, teacher, how a global unicast IP address will be available? Okay, the global unicast IP address will always start with 200. Note down. So if you see 200, okay, if any IPv6 address, if it starts with 200, okay, write it 200:/3. So if you see 200, okay, that is a, okay, what is that? That is a global unicast IP address. Okay, please note down. If any IP address, if it is start with 200, okay, if any IP address, if it is start with 200, okay, it is a global unicast address. Now, okay, I'm going for this. See, in this 2001, 200, first three is 200. This is a global unicast address. Then I'm going for this address 200. This is a global unicast address. Okay, global unicast address. So easily you can find, okay, a address is a global unicast address. This is the formula I'm giving, techniques. Okay, so 200 means it is a global unicast address. Write it in a paper like before. 127, sorry, 126, 128 to 191. You memorize that. Same like this, you have to memorize this. Then link local IP address. Link local IP address will always start with FE80. FE80:10. What is the 10 means? Okay, I'm not explaining that, no need. You can just take FE80. So if any IP address, if it is start with FE80, so that IP address is called, okay, it is a link local IP address. Okay, link local IP address. Then loopback. Today we solve this. What is a loopback IP address means? Today we solve this. Okay, that means 0000, everything 0, the last bit is 1. Okay, we applied rule number 1 and 2. We apply the rule number 1 and 2 and we solve this. Okay, :1. That is called a loopback IP address. So loopback IP address means :1. That is a loopback IP address. So this numbers, you have to keep it in your mind. Okay, this is very important. So if any IP address they give, you can easily find it. Then Unique local. So unique local IP address, it will always start with, okay, you can see FC00. FC00. So it will always start with FC00. So that is called a unique local IP address. Okay, write only 4 in unicast, global unicast, link local, loopback, unique local. So global unicast 200, link local FE80, loopback all 127 bits 0, only the last bit is 1. Then unique local FC00, FE80, FC00. Okay, so this is unicast. Unicast is completed. Now go for multicast. So in multicast we have 2 types, okay, or generally multicast. Always multicast IP address you can see by using FF. Okay, multicast IP address, it will be usually in the form of FF00, FF10, FF02. Okay, mostly, not mostly, it will start with FF. Okay, multicast IP address, there are 3 types available, that is okay. But if you want, you can write it. Well-known IP address, transient IP address, solicited node. There are 3 types available in the multicast. Okay, the entire lecture is this. If they ask any questions about multicast, you can write. There are 3 different types available. It is well-known, transient. Okay, you can write. It will start with like this. I'm covering the entire lecture now. So well-known IP address, that means well-known multicast FF00. Transient, okay, transient multicast FF10. Solicited node FF02. So very simple hint. What is the simple hint? You will always have FF. Okay, FF, that means the multicast address will always start with FF. Okay, you see, any other address, it will not start with FF. Okay, no one will start with FF. So FF it starts, it is going to be multicast. This is the point. Okay, I repeat, global unicast 200, link local FE80, loopback all 27 bits 0, last bit will be 1. Unique local FC00. Well known, okay, all multicast FF. Problem over. Okay, so this is about lecture number 2, IPv6. Tomorrow, not tomorrow, I have another 2 weeks we have. Okay, we have another 2 weeks. This is 13th week, 14th week, 15th week. Lecture number 13, I'm going to give video only. I'm not going to teach. Next 2 classes, next week 2 classes, I'm going to do the same thing. Okay, not same thing means don't think lecture number 1 and 2. No, I'm going for lecture number 3, lecture number 4, lecture number 5, like that. So in all these things, I'm going to give summary. The next lectures, okay, if you go for, okay, the next one is going to be the static root. You must know how to write the command, because in exam, they will ask only the commands. Okay, they will ask only to write the commands. Okay, so in the lab you are doing, but in the paper, you have to write the command. Once if you write the command, things will become very easy for you. Okay, so don't miss next 2 classes. Next 2 classes completely we are going to do like this. Complete all 13 lectures we are going to cover. Okay, I'm not giving any important things here. I'm giving, okay, the overall idea. Now if you go and see your lectures, you will find very easy. Okay, so lecture number 13 soon I will upload. Okay, I will upload the video for 13. Next 2 classes I will finish. Okay, because this is taking time, because this is calculation and all. But next lectures it will not take time. Next week first class, that means on Wednesday I will go for lecture number all roots, static root, dynamic root, OSPF I will complete. I will write the command and show it to you. Then next week Thursday completely about the LANs, VLAN, inter VLAN. Okay, all these things I will write the command in the paper and I will show it. Okay, I will give the overall idea for you. Okay, so is it clear? Is it clear? First 2 lectures summary is okay.
Clear. Yes.
Yes, yes, very good, very good. So Friday evening around 4 o'clock, 5 o'clock, I will send the, okay, the concept. That means I will send the question to you. Inter-VLAN communication, okay, single and multiple. I will give the question paper. You have to do it in the packet tracer and you have to upload it in 24 hours. Next weekend, after finishing all these, okay, lectures, I am giving summary. After giving that, we are going for the last one, that is going to be the open book exam. So the open book exam is, okay, I will cover everything, whatever the things, whatever I feel, it is not important, whatever I feel important in this course, like I will ask you to write the command for static route, for dynamic routing RIP protocol, OSPF, okay, like this. So we are going for a open book test. So that will be like 1 hour or 2 hours. We will fix the time later. That is next weekend. Okay, so with that, we will finish the course. Okay, so thank you very much. You can leave today. I'll send this video. Okay, I'll send this video to you. Okay, you may leave now. Thank you. Don't miss the class. Okay, please kindly don't miss the classes next week. Very important classes, don't miss.
Mr.
Yeah.